This presentation is on network storage. As the reliance on networks increases and more data is stored in a central location, we need to start finding ways to store large amounts of data on a network so that devices can access the storage. As you're aware, the largest capacity for a mechanical hard drive is around 3 terabytes. So we put hard drives into storage arrays so that we can increase the capacity and that the actual machine will only see one logical disk. There's also added benefits in data redundancy. But basically, a disk array is a hardware element that contains a large group of disks or hard drives which are stored on server racks. As you can see in the picture here, the storage arrays may contain several disks on a tray. As the architecture improves, the speed is increased and data protection is also increased. The system runs via a storage controller which coordinates the activity within the unit. So basic operating systems like Windows or OS X have RAID controllers which allow you to organize the physical disks into one logical storage array. A storage area network, or a SAN, contains one or more disk arrays that function as a repository for all the data which is moved in and out of the system. The configuration of disks into an array is referred to as RAID, which is a redundant array of independent disks. By placing the data on multiple disks, the input and output operations can overlap in a balanced way, which improves the performance. RAID appears, as I mentioned before, on the operating system to be one single logical hard drive disk, and the technology divides and replicates the data over the multiple disks to give that redundancy and parity. There are many different RAID configurations, but the two we focus on our syllabus are RAID 1 and RAID 0. So RAID 1 is also referred to as disk mirroring. So this is where the data exists on two independent disks, so that if one of the disks fails, then you still have the other disk up and running. In this function there's no striping. In RAID 0 it uses data striping. Striping is the process of dividing a body of data into blocks and spreading the data blocks across several partitions on several hard disks. This technique allows for the best performance, however there's no fault tolerance like there is with RAID 1. From the diagram at the top you can also see that there's a difference in the hard drive capacity depending on which configuration you use. So you can see in the mirroring example we have two 1 terabyte disks which have the same data on each of them. So you can see that file A copy 1 and file A copy 2. So the two 1 terabyte disks only allow for 1 terabyte of combined storage, whereas in the striping example, the two 1 terabyte hard drives actually add up to the 2 terabytes as it should. So there is no loss in our capacity for storage. The other type of RAID configuration we look at in our syllabus is RAID 10. So it's actually RAID 1 plus 0. So it combines the two common types of RAID configuration to give the best of both worlds. So this allows us to have the striping as well as the mirroring. So you can see here we've got the RAID configuration with 4 drives. There's mirroring across 2 of the drives, so if there's any failure at any point you can easily move the data across. So when we have this kind of redundancy, it's called disk parity. So parity computations are used in RAID drive arrays for fault tolerance by calculating the data in 2 drives and then storing the results on a third. After a drive fails, it's replaced by the RAID controller and builds the data up again on, from the other 2 drives. It's also referred to as having a hot spare drive, which means that you can quickly remove the failed drive and then it can quickly rebuild the data. There are 2 common methods of network storage, which are the storage area network, or SAN, and network attached storage, which is NAS. The NAS is a specialized server with a RAID array that is placed on the network for the sole purpose of providing storage to the users through the attached network. It usually uses a small embedded operating system and provides a file-based storage to the other devices. The NAS unit will connect to the network using TCP/IP, which is the Common Internet Protocol, and will appear to users as a separate network location. So a NAS will provide file level access, whereas the SAN provides block level storage. The NAS has a file system so that clients can easily retrieve their files, so it just looks like a normal Finder window or Windows window. NAS appears on the network as a network location, so it uses protocols like NFS, SMB, or AFP. So it's our standard Windows, Unix, and Apple protocols for file transfer. NAS is also commonly used for the storage of documents and files or media servers, whereas SAN is more for network and map drives. A SAN is a high-speed special-purpose network or subnetwork that interconnects different kinds of storage devices with associated data servers on behalf of the large network of users. It is a network that is dedicated to transporting data and storing and retrieving data between input and output traffic between the servers and storage devices. Typically, it's joined by a fibre channel, which allows for quick transfer between the different interfaces and different file servers and the storage arrays. So fibre is used because it's only a short distance between the two, and also it has that high bandwidth so we can quickly transfer the information. So as mentioned previously, the SAN provides block level storage rather than individual file level access, so you can actually provide chunks of data to users rather than individual files. The SAN has chunks of data which are retrieved and assembled for the client. So for example, like student drives, we assign 150 megabytes worth of data to each student, and as they log in, it appears as a normal C drive or boot drive for each of the students. SAN appears as another disk that can be mounted like any other external disk, as I just mentioned. The SAN is also most commonly used for storage of data that is easily broken up into chunks, such as databases. A wired transmission media is used to connect the storage arrays to the rest of the network infrastructure. So as you saw in the diagram, the SAN fibre channel is used because it's high speed and there's a short distance. iSCSI used to be used before, but it's now been outdated by fibre. Fibre's become much more affordable. NASs are typically joined to the network through a standard Ethernet interface, and then it just connects to the network infrastructure. Sometimes networks, the NASs do have two network interfaces, which allows for load balancing between the different interfaces, so you can have ingoing and outgoing, or it can have both ingoing and outgoing through the same interface, and that can be balanced depending on the requirements on the NAS. With fibre channels, each server needs to have a specialised network card which connects to the fibre channel or the fibre switch. Specialised devices means greater expense and also complexity when setting up the network and also maintaining it. The fibre channel connects to the SAN through a number of storage arrays, and then it connects also to the server. The fibre channel fabric is optimized for large block transfer, so large amounts of data at a time rather than individual files. So as mentioned previously, the NAS is normally connected through an Ethernet interface, which is typically 1000 base T, which is a gigabit Ethernet port. Some of the high-end NASs do have the two interfaces which allow for the load balancing features, as I mentioned previously. After listening to this presentation, you should be able to understand the difference between a NAS and a SAN. You should understand the transmission media which is used for each of the network storage architectures, and also understand how it fits into the network infrastructure.